Hi students. Hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see maximum power transfer theorem. So this is very important topic in this particular subject and it is very basics for both EC and as well as triple E students. In this video you will see what is maximum power transfer theorem, what is the procedure to solve maximum power transfer theorem, and we'll see problems, right? First we'll see what is maximum power transfer theorem. According to maximum power transfer theorem, it explains that to generate a maximum external power through a finite internal resistance, the resistance of the given load must be equal to the resistance of the available source, right? That is, it says that it can able to transfer the maximum power to the load only when the load resistance is equal to the source resistance, right? We can also say in other words, that is, the load must be equal to same that of the Thevenin equivalent resistance, right? Thevenin's theorem is very important theorem where if you understand Thevenin's theorem, you can definitely solve maximum power transfer theorem as well. Because we're going to follow the same steps what we have followed in Thevenin's theorem, right? So you can see here, if you take, according to Thevenin's theorem, we say that any linear circuit can be simplified into a equivalent circuit with source voltage source in series with the resistance. Here what we are saying is the same concept, but the maximum power can be delivered if RL is equal to this RTH. That is the concept of maximum power transfer. So here also you can see we have VTH, RTH, and then you'll find out RL. Right? So we have to follow the same procedure for Thevenin's theorem. Right? Whatever we followed in Thevenin's theorem, we're going to follow the same steps for maximum power transfer theorem. At last, you have to calculate only the power. That is the only difference, right? So these are the procedures to solve. First step, you have to draw the Thevenin equivalent circuit, and then you need to find out VTH. You know how to find out VTH, right? If you don't understand this, please go through the previous video of Thevenin's theorem so that you can understand. I have explained how to find out VTH, how to find out RTH, so that you can easily understand it, right? So to determine VTH, first step, what we have to do, we have to remove the load resistance, and then we know find out the voltage across the AB, and then you need to find out RTH. How will you find out RTH? You have to remove the load resistance and you have to kill the source, right? Whereas for killing the source, what we have to do? We have to short circuit the voltage source and open circuit the current source, right? And this is the final step where normally what you will do is you will find out the load current in Thevenin's theorem, but whereas here you need to find out the load current and as well as power. You can see the current can be calculated using this formula, VTH divided by RTH plus RL, or else we can find out P max is equal to power is equal to V square divided by 4 RTH. V square is nothing but V RTH, right? So this is the only step that differs. All those things are same like Thevenin's theorem, right? So now we'll see the problem. So you can see here what is the question they have given. Using maximum power transfer theorem, find the maximum power delivered to the load RL, right? So now the same steps you have to do. First you have to draw the equivalent circuit. Equivalent circuit. Where equivalent circuit you have to find out VTH. This is RTH and this is RL. RL they have not given here, whereas in Thevenin's theorem they will give RL. Here they will not give RL value, right? So now what we have to do? We need to find out the VTH. Now what we will do? We have to remove this RL, right? Remove the RL, and then you will have to have this voltage source, right? And you will find out VTH, correct? So it will be like this. The circuit will become like this. Like this, correct? This will be 100 ohm. This will be 100 ohm. This will be 200 ohm. Same circuit. Same thing what we did in Thevenin's theorem. Now what we have to do? We have to eliminate this because it is open circuited. right? And now we consider this mesh, two meshes, and find out the current flowing across this particular resistor, and we find out VTH. And after VTH, we find out RTH. How will you find out RTH? You have to remove the source and as well as load resistance. And once you find out RTH, we find out uh, we have to substitute this in this particular circuit, equivalent circuit, and then you can be able to find out the power value. Power value, I have already given this formula. What is if we find out VTH and RTH, you can actually calculate the power. The power that is calculated is the maximum power, right? So whatever I said, that is what we're going to do here. You can see here for the same circuit. First thing I have drawn is I have drawn Thevenin equivalent circuit, and then I have removed the load resistance. Whereas I've taken this circuit, we know that how you form this particular matrix, right? We are taking matrix method, that is R11, R12, R21, and R22, right? And this will be minus because of diagonal elements, correct? So you can see here for R11 the total resistance here 200 plus 1 300, right? And the common resistance is 100, so it is minus 100, and this is also minus 100 because R21 it is common between 2 and 1. And this is another resistor, another R22 is nothing but the complete resistors, 100 plus 100 plus 150, oh, sorry, 50, 250 totally, right? So from this we can able to obtain I2. Why is that we are going up to? This is the current that is flowing here. I2 is the current, right? So with that we can able to find out VTH, right? So 100 into this particular current that gives you the voltage across this particular terminal. And find out RTH, what we have to do, we have to remove the load resistance and also short circuit the voltage source. Right? Now what will happen? You have to approach the circuit from this end. And if you approach this particular from this end, we know that this becomes parallel, right? So now if you parallel it, we'll have 50 ohm here, correct? And then this becomes series. This 50 and 66 becomes series, correct? And now again what happens? These two becomes parallel, right? And if this becomes parallel, then what happens? You have to solve it. I will obtain this value, right? And that will be added here to 200. So this will be the total resistance, which is RTH. And now we will find out RTH and as well as VTH. So you will find out what is the RL value. How will you find out RL value, right? So you can see here, you substitute the values here, right? VTH and as well as RTH, and according to maximum power transfer theorem, we know that maximum power will be delivered if RL is equal to RTH, correct? So RTH and RL will be same, right? So now how will you calculate power? Power is nothing but VTH square divided by 4 RTH. If you substitute the values, you will obtain 20.9 milliwatt, right? And similarly, you can also find out IL current. What is IL current? V divided by R. If it is VL, we have to find out I. So it is V divided by R in the sense R, you have to consider both this resistance. It's series, right? So it is 9.1 milliamp. 4.62 divided by 253.84 plus 253.84. We can also calculate power in this way, that is current I square into R. I square into R, that will be RTH. Right, you can also calculate that, but the power will be a little different, 21 milliwatt. Right, small difference will be here. Right, so it is the same steps we have to follow. The only difference here is that at last you will calculate power using VTH and RTH value. Okay, so today what we have seen is we have seen maximum power transfer theorem. Right, what is now maximum power transfer theorem? We have seen the procedure of maximum power transfer theorem, and you have seen one particular problem, right? I believe this video will be useful for you. Thank you, my dear students.